All right, guys. Anybody have questions from homework? Yes. There's less people to fight to ask a question today.
3.334.
Oh, I like it. All right, so this one says, for what value of x does this thing have a horizontal tangent? This is the one, right? Always love it when I get halfway through a problem. I mean, that's not the one. So what's horizontal tangent line mean? It's where the slope is 0. So obviously the first step is. Alright, do it. If you haven't done this one yet, we'll just sit there and say, I did try it. If you haven't tried this one yet, try it. Of course, what rule are you using primarily? Product rule. 11. So product rule says derivative of 1, and then the other guy gets a turn. So here you get e to the x, keep gas. And derivative cosine is negative sine a locket. And then you take this and you set it equal to 0. One thing to realize, I mean, you're going to solve this sucker. Calculator. Shit, no. Sorry. No. Unless it says, use a calculator. No. Right. How do you solve something equal to 0? What's the primary thing you do? For a lot of things equal to 0, what do you do?
Could we add, like, e to the x?
You could, but you could also factor out e to the x, right?
So,
you have something equal to 0, you think factor very often. Right. Can somebody tell me, can e to the x equal 0? No, it's got that, it looks like this, it's got a, for you guys, it looks like this, it's got a tangent line, it's got an asymptote, sorry, at 0, so it's never going to equal 0, so this gives me no answers. So now I can investigate this, I'll do like you said. Alright, you guys ready? You're at the point now where you don't have to brute force everything. What does this equation say? Cosine x is equal to sine x. We know where that happens. Sure, that's one place. Does it have any restrictions on the answer? Meaning, does it say within this interval? Because what's true about trig function values, they are periodic. Right? So it's pi over 4 is one place. Cool, right? We know this. This is asking, where's cosine equal to sine? Where does that happen? Pi over 4 is one place. Where's another place? What about 3 pi over 4? What's wrong with that? What's wrong with 3 pi over 4? Yeah, cosine's negative. Sine isn't. So it's the first quadrant and the third quadrant, because in the third quadrant they're both
positive.
negative. so that it's possible for them to equal each other. So what's the pi over 4 reference angle in the third quadrant? 5 pi over 4, kick ass, because that's a full pi, yum, and I don't want to go pi over 4 past that. So that's 5 pi over 4.
So you're basically finding where they're both negative or they're both positive?
I am finding where they are equal to each other, because that's what the equation says.
But is it equal in terms of like number?
Equal. So if one is negative and the other is positive, are they equal? No. Okay. Now, am I done? What's a better way than, I mean, if I try to list all the answers, I would so desperately suck. Because negative 3 pi over 4 also works, right? What else works? Let's just do another one. I could go 2 pi plus pi over 4 to get back here, right? But tell me, how far apart are the main things that work? Here's pi over 4, here's 5 pi over 4. How much is this? Pi. So how much is this? Still flipping pi, right? I'm just flipping pi. Come on, guys. Come on. This is not difficult. So how do I write this better? Pi over 4 plus who? Say again? Yes. Well, no. Well, k pi. You don't want to make it x because that could be any real number. K is kind of like that stand-in for any integer. Right? This should sound unbelievably familiar to you. Unless you've never taken trig, which would explain a few things. But supposedly everybody in here is taking trig. That has to look familiar. Has to. No? Yes? If you don't remember trig, guess what you should have done before today? Reviewed the shit out of it. Right? I was hoping I made that point really clear. This should be a quick problem. Once you get the derivative, factor it like you always would. Something equal to 0. And then this is a trig equation. It's got a very simple idea to it. Where are these two equal to each other? Now, could you divide by cosine? Sure. What do you get when you divide by cosine? Tangent equals 1. Now, tangent equals 1 when sine and cosine are equal. Right? So it doesn't really change what you're thinking at all. Sine and cosine are equal. Sine and cosine are equal. They say the same thing. So the calculus step should be the new stuff. If this does not sound familiar, this whole thing right here we did, that's a bad sign. Me being an asshole is you not coming in prepared. You're supposed to know your trig. Okay. Again, I am here to help you. I got office hours right for advice. You can come and ask me any damn question you want to. I'm not going to belittle you or something. I'm going to say, okay, here's how you do this, here's how you do this. But in class, I have to teach calculus. In my office, I can teach you any damn thing you want me to. All right? What's 3 times 2, Jeff? Here, let me show you. I will show you. Yes?
I got a question from 3-1.
Okay.
So for 81, are they just like looking for rules to define N and B?
Oh, all right. That's a good question. 81. So in order to be differential, so let me I said this before, but it might have gotten lost. For something to be differential, do you remember, like, is this differential? Why not? Okay, now go beyond that. That's a shortcut way to remember visually. But really what's happening is, if this truly is the absolute value of x, what is the slope here? Yeah, here it's -1. And then here, it's 1. So in order for something to be differentiable everywhere, it has to be, its derivative has to be continuous everywhere. So this derivative is discontinuous at that point. That will happen with any cusp, because that's like an instantaneous big change in the slope. That is a plane you don't want to be on it. Or slammed up against the side and a big bloody mass gross. I'm not in calculus today. Big bloody mess. So this guy, they give you a piecewise function. What's true about the parts of this piecewise function? Here it is. Each part. So the thing is asking, find the values of m and b that make f differentiable everywhere. What's true about x squared? Is it differentiable everywhere? Yes. What's true about mx plus b? It's a line. Is it differentiable everywhere? Bless you. Yes. So the only place this could possibly be this not differentiable would be at 2. So you have to force the right thing to happen at 2. So what is it that needs to happen at 2? Yeah, the slopes from both sides have to equal. Right? So you can do the derivative of this, and do the derivative of that. And make them equal each other at 2. Now what else has to be true? So that's one thing. Make derivatives equal. What else has to happen? Because here is this has got a slope of 1, and it still has a slope of 1, but is that differentiable? No, because right here it is not continuous. So it's a second stipulation. Thank God, because how many things do I not know up here? 2. Anytime I have 2 things I don't know, I need 2 pieces of information. So one is make the derivatives equal at 2. And the other one is make the function itself continuous at 2. I like it. Once you realize what to do, the problem becomes really stupid easy, but the reason this is at the end of the section is because you've got to realize it's a 2-tier thing here. There's a couple things you have to make sure happens. Okay. I like it. Anything else? Any other questions I can go on a rant about? Hopefully not. Yes?
So for 64, part C.
Still in 3-1?
Yes. Actually, part B.
Part B, okay.
They asked for you to draw a diagram. Do they just mean like a graph? Or?
Yeah, draw a graph.
Okay.
Yeah, sketch a graph. That one's a really good problem. I like it. There are certain problems that if I never hear any questions about them, that tells me no one's doing the homework. There are certain problems that are just very strange. And it's fine to ask questions. You're not supposed to be able to do all these automatically, then why the hell would you be in this class? So asking questions is fine. If you don't, then I'm worried. Yes?
One of them was quiz.
Oh, okay, good. Well, all right. I mean, that's one thing we're going to talk about today, but we have made it through. This is not our fault, by the way. I've already decided this. Yeah. So 3-1 through 3-4 quiz on Monday.
Tuesday.
I don't think I've ever taught a 180 class on Tuesday, Thursday, so I'm freaking out. And more than likely, on Thursday we'll have another quiz, but I'll have to announce Tuesday what it's going to be on. Probably 3, 5, 3, 6. We'll see. Maybe even 3, 7. We'll see what we get through today. Anything else from homework stuff? All right. So I want to just talk a little bit about a few more derivative rules, and I'm going to unleash you on a group worksheet. And then we'll go over the group worksheet. We'll see what else time we got left after that. So last time we barely got into this idea of implicit differentiation. So really, I desperately want this to make sense. If I said, what's the derivative of sine x to the fifth? What would that mean? Yeah, the main thing is a power rule, right? So 5 sine x to the fourth times. Yeah, what is this piece going to be? Times, let's just write the rule down, right? Is that cool? And then that's cosines. I did this the other day, but I really want to shove this in your face, because the more you get what I'm about to say, the normally you get it. This is exactly what implicit differentiation is. Doesn't matter what the shit function I put in there. So like, what's this derivative? Yeah, 5 times thing to the fourth power times derivative of thing. Right? Hopefully everybody understands. I'm not going all the way for one more step. But here's the idea. So no matter what function I put in there, so let's say I'm not even going to tell you what function it is. I'm going to say it's some function of x. I'm going to say it's some y. There's some y. I'm not going to tell you what the function is. How far can you take this? How do you take this derivative? That's the heart of implicit differentiation. Right? That's it. Anytime you take a derivative of something that is a function of x, you have to multiply by the derivative of that piece. That's all that says. We already know that, we know that, we know that, and then suddenly it doesn't make sense. But here's what a problem is going to look like. So it can look like this. X cubed y plus y to the fifth equals, what you got, Jeff? Y minus x. So the instructions are going to say find, most of the time they're going to say find dy dx. The reason they do that, I'm going to show you also you could find dx dy. At this level you should realize that x and y, it's arbitrary. Who cares which one I call which? How's the coordinate system? Maybe it's like this, maybe it's like this. Really the variables don't matter. You can go either way. So let's find what we're used to first. So to find this, I have to take a derivative of both sides. Let's do this side first. What's the derivative of y? dy dx. What's the derivative of x? So let me see if you guys can see this. So what am I doing to both sides? I'm applying the d by dx. I'm doing that to both sides. If I do that, what's dx dx? Dx over dx is 1. All right, and plus we already know the derivative of x is 1. But the notation actually shows you it's the dx divided by dx. It's 1. But what's dy dx? I don't flippin' know. Nobody told me what y was. So this notation is very helpful to keep track of what we're actually doing and why things come out. Why didn't I put something weird here? Because it's dx dx. It's 1. Why is that not 1? Because it's dy dx. I don't know what the shit that is. right? Because I don't know what the y is. What about this side? What do I have to do here? Beautiful. So it'll be x cubed prime y plus x cubed y prime. This one we just did, right? 5y to the 4th times dy dx. I'm kind of mixing my notation. So what's the derivative of x cubed? 3x squared. And what's the derivative of y? Dy dx. This is kind of awesome. I mean, this is actually, if I have a relationship between values of variables, I can take a derivative and get a relationship involving rates of change. I mean, that actually starts to get into real world shit, right? Because I normally know flow rates of stuff. I can measure how much stuff goes by. I can work with rates of stuff. Now, it says to do this. Alright, so this is, just make you feel bad if you can't do it. It's mathematics shit. So try to do the next step. Figure out what dy dx is. You're really just solving for this dude, right? A couple different ways to go. You can choose which side to move stuff to. So I don't know which way you guys went. Personally, I would do this. I would add the 1 and subtract these over there, just to keep more things positive. But you guys subtract this guy, that'll work too. You want to get everything on one side that's got dy dx. What do you do in math and algebra to solve for x? You get everything that has x in it on one side. Maybe you factor an x out and then divide by shit you don't want. That's exactly what you do here. So let me just do what I think most of you probably did. I think most probably subtracted this guy and then subtracted this guy. Wrong. So now I can take a dy dx out. X cubed plus 5y4 minus 1. Oh, that's what I always do. I just always skip that step. Now I divide by the stuff I don't want. This is going to happen just about every time. So then I get dy dx is -1 minus 3x squared y over x cubed plus 5y4 minus 1. Okay, all right. You guys try this one. I'm going to try to pull something up on the computer real quick. question? Let me try to catch up to you guys. So we're going to do d by dx to this whole thing. So how to do this guy? It's the main thing here. It's just the fact that it's sine. Right? So what do I get? Your sine is? Cosine of stuff. And then the inside gets a turn, right? Let me write this more formally. That's another way to write prime. Minus, what happens here?
Minus e to the y times y prime.
I like it. Yeah, good. Negative. Or sine. So anytime you take a derivative of a piece that has y in it, you have to tack on a dy dx. That's chain rule, because y is a function of x. Can I solve this for y? Can you solve this for y? If you can, teach me. This is really insane. E to the y. I'm not going to be able to do e to the fourth power. So I got to remember, I got to make my y's like super duper, not fours. Oh shit. So I still have this to do, right? So I have cosine of xy times
X prime y.
yeah. So d by dx is 1 times y plus
X times dy dx.
I like it. XY happens so much, you're going to start to kind of memorize this form. You see a lot of XYs running around in the wild. Now it's just algebra. dy dx is a variable that I'm solving for. Right? So I distribute There's very few things that don't have a dy dx on them, right? Just this one dude. So I'm going to subtract him and add this guy over so I get all my dy dx stuff on one side. Right, okay, so I'm going to put that 4 sine y dy dx plus x dy dx cosine x minus e equals. Subtract him out of here. You got no dy dx. Get this shit out of here. So you guys can handle this and get tired writing all this stuff out. I'm going to take what I'm going to do next. I'm going to take a dy dx out, and then divide by the stuff I don't want, right? So can't I just pick off, so I'm going to divide by 4 sine y plus x cosine xy minus e to the y. Is that cool? Is that right? Take a dy dx out, and I'm going to divide by all the shit that would be left. I'm going to divide by it because I don't want it on that side. So now if somebody gave me a point that this thing goes through, I can figure out what the slope of this is at that point. Now the graph of this is a little more interesting than I wanted it to be. Maybe I'll still show it to you, but I want to first show you the graph of this one. Can you turn off the one that says whiteboard? I think the one that says inboard is the one that says that. Maybe try it one more. Now turn that one back on. Do the other. Yeah. Cool. I like it. So here's the plot of that one, the first one we did. Look at this. This is really kind of interesting. So see, that's definitely not a function. It's also got a very interesting aspect to it. This is a part of the graph. Right? So what is this related to? What is this line? What is that line? What's the equation of this line?
X equals -1. Or y.
Y equals -1. Y is up and down. If I don't go up and down, y has to stay constant. That's y equals -1. What's true when I put y equal to -1 into the equation? I get negative x minus 1 equals -1 minus x. So if y is -1, I get an identity. I get a true statement. So if y is -1, x can be anything it wants to be. For any other value of y, I have certain values of x that make it true. I like it. We calculated the derivative at any point. Right? So there's definitely a derivative here, there's a derivative there. I mean, there's slopes there, right? The only weird part would be right here. You can see that even this grapher is like, that's weird shit. I don't know what to do. Maybe. No. So, I don't know. Wolfram Alpha, you don't have to pay any money to be able to graph things like this. That's one of the main ones to go to do these funky implicit stuff. If you just start playing with this, it gets a little interesting. There you go. That is fantastic, right? I mean, so most of these, it only kind of makes sense. If you can't solve for y, it more than likely is not a function, right? That's not a function. Why? Fails vertical antics. I love it. I like it. So there's actually certain equations you can get that create shapes. There's like a butterfly equation that I can look up. It's kind of long, but it actually kind of traces out a butterfly. I'm like, oh, you guys did a little parametric stuff in pre-calculus. Remember parametric stuff? X equals a function of t, y equals a function of t. No? Yes? No? No, okay. Shit. Well, that's where it gets really flipping cool. When you're able to control each variable independent of each other. They're both dependent on some third thing behind the scenes. Then it can do all kinds of weird ass shit. Neat. Okay. Just to show you. Let's see. Is it still? And here's what this one, that second one we just did, here's what it looks like. Oh my God. Oh my God. Yeah, so it's got a lot of special cases kind of there. Is it related to that straight line we had? Yeah. So these are not going to be necessarily intuitive results when you have these things that you can't pull X and Y apart. They are not going to be immediately like, well, yeah, of course it looks like waves. Like the little ripples on a pond. What? Okay, maybe. So you don't have to pay. You just go to Wolfram Alpha. You guys, I know most of you have heard of Wolfram Alpha. I'm almost certain because that's the one you pay a little bit and it shows you all the steps to solve a problem. Yeah. Better than that photomath shit, because once you get to a certain level, photomath goes on. I don't know. So photomath only helps you so far. If you have no idea what the things are I'm saying, that's good. You've probably actually learned math. Right? Instead of your phone going, here's the answer for you. All right. Okay. Can you pull them house lights back up? Thank you. By the way, Wolfram Alpha, 1% of what it does is math. It does like everything. It's insane. You can type in there, how old would Albert Einstein have been when, I don't know, when Trump met Kim Jong? Who is that? Right. How you can do how many angels can dance on the head of a pin? You can do like little Easter egg things like that. You can type in chemical formula and it will break down all the properties and show you an example of what it looks like. Oh my God. Type in your last name. It'll tell you the distribution of how many people have a name, how old they are, blah, blah, blah. Yeah. Okay. So you should play around with Wolfram Alpha a little bit. Let me do one quick, easier example, just so I can show you a dx dy thing. So first I'm going to do dy dx. So find dy dx if for what you got to. Let's just do y squared minus e to the y. So, 2. Let's make it 2x. Just think ahead. So just do this together. This is going to be a product rule. So derivative of the first guy, leave the second guy alone, plus derivative of the second guy, leave the first guy alone. We did this guy just a minute ago. And this guy is just 2. Just one piece out of place. Right, this thing here. So I'll get dy dx, x squared minus e to the y. 2 minus 2y x, right? Subtract that, take a dy dx out of the other 2 pieces. So then you get dy dx equals 2 minus 2yx over x squared minus e to the y. Okay. It's a nice quick little example of implicit. And again, implicit differentiation is built right on the back of chain rule. It's just chain rule. That's all it is. So now let's do the same thing, but we'll find dx dy instead. And then I'll show you something that really have to agree in case a lot of this. So this means that I'm going to apply d by dy now to both sides. So what is an implicit function of what now? X is an implicit function of y now. Right? Side note. What's this? Yeah, it tells you the slope and the y-intercept, right? There's no reason in hell why we couldn't have made it this instead. No real reason. Right? This now would be the x-intercept, and this would be run over rise. I think it's just chosen way. Let's do it this way. That's a little more to it, but still. X and y are completely arbitrary. Turn the whole flipping thing over. In fact, in later courses, you might learn how to, well, here's an equation. What happens if I just rotate shit and leave the equation where it is? What happens to the equation itself? Oh, shit. No, let's not do that yet. So, here, x is some function of y. I have no idea what it is, because I can't solve this damn thing for x. So let's see. What do I get? So d by dy. So this guy now, d by dy y, 1 x squared. So the derivative of the first times the second plus the first. Now what's the derivative of x squared? 2x dx dy. Kick ass. For the same exact reason. Now x is some function of y, so when I take its derivative, there's the chain rule piece. Exactly the same way. What's the derivative of this now? E to the y. Done. Right? Because y is just y. Equals, the derivative of this is going to be 2 dx dy. Kick ass. Now I just solve for dx dy, right? This is the only guy that's out of place. So x squared minus e to the y. I'm going to subtract him over. Let me see if I can take dx dy out at the same time. I'm going to subtract this piece over. Is that cool? Subtract him over, take the dx dy out. I'll get 2 minus that guy. And then divide by this guy. So I get dx dy. Now I'm hoping to God somebody out there had the fleeting thought that dy dx, whatever I get, dx dy should just be the flip of the thing. And it is. It only makes sense, right? dy dx is that. So what's dx dy? Flip that. Doesn't that kill your ass? So on one level it's like, duh, but on another level you really wouldn't expect that. It's like, this is too complicated. Can't be. No, it's exactly that. Oh, thank God. Maybe? No, you lost me. Good morning. Okay. So, now that we know implicit a little bit, I want to go back. Remind me, what's the derivative of e to the x? Oh my God, that's so awesome. Right. And now I actually have to start being a little more explanatory on my notation. The prime notation is kind of what's the derivative with respect to. That's why this notation generally is better. But when we see prime, it's normally going to be dx. Right? It almost has to be. Anything else has to be explained to me which variable am I dealing with. So what the hell? E was a special base. We talked about it a while back. So what happens to the bases that aren't e? What happens if my function is freaking 4 to the x? I don't know. So let's play with it a little bit. So y is 4 to the x. Can I rewrite this? We can do this. Yes. Even a little bit better. I appreciate you going there. Let's just say natural log of y. Right. Natural log of y equals, bring the x down. Right? Now, if I only knew how to take the derivative of natural log, I could figure this out, right? I could do implicit differentiation on both sides. Now, to be honest, now I can do this. So if I knew natural log of y, if I knew the natural log derivative, which is the next thing we're going to do, I could just do it right now. I don't know the derivative of natural log yet. So how can I rewrite this? What's the base here? E to the that equals that. So y equals e to the x natural log of 4. Some of you guys might know just to go straight there. You can always take something like this and write it like e to that. Always and forever. That looks gross, but this is really, really easy. How do I take this guy's derivative? What is ln for? What kind of thing is it? It's just a constant. It's just a number. It's like 2. It isn't 2, but it's like 2. So what's y prime? What's dy dx? Well, what's the derivative of e to something? E to that thing. Times the derivative of this. What's the derivative of this? No. This is like x times 2. What's the derivative of x times 2? Better known as 2x. What's the derivative of 2x?
Derivative of x times L4 plus x.
No, don't overthink it. This is a constant, guys.
L4x?
No, just ln4. What's the derivative of 5x? 5. What's the derivative of negative 7x? Negative 7. So what's the derivative of natural log of 4 times x?
Oh.
Natural log of 4. You see why we don't write the ln4 first? Because then I have to put the little... So you know it's not natural log of 4x. That is just a constant multiplier. That's it. Like it? Now, help me out. What was e to the x ln 4? It was 4 to the x. So in general, this is kind of beautiful. You guys are like, I don't think you know that word means. If f of x equals, say, a to the x, then f prime of x is a to the x times ln a. So that isn't e. This is a little adjustment to make it true. E is the only one who's its own slope, has its own slope, right? E is the only one that defines its own slope. It's itself. Anything that's not an E base, that's the little adjustment for it. Kicks. You know we say this a lot. So what if A is E? What's natural log of E? 1. Okay, we recover the thing we already knew. Right? I got one person that's giving me some nice, like, oh, okay, I can live off of that. Okay, now, so that is another formula, another derivative rule that you must know, how to take the derivative of that. So real quick, what if f of x equals 3 to the x squared minus 7x? What's that guy's derivative? What rule is this going to use?
X squared 7x.
It's going to have, so what's the derivative of 3 to something? What's the derivative of 3 to the something?
Am I doing it wrong?
Maybe, probably. What's the derivative of 3 to the something? 3 to the something times natural log of 3, right? That's what it says. Times, now what rule comes in? Chain rule. I like it. The derivative of this guy. Every time we learn a new function's derivative, all the rules we've learned still apply. The rules are not defined by functions. The rules are the rules. So every time I learn a new function derivative, chain rules works the same. Product rule works the same. They can't change. So this would be 3 to the x squared minus 7x times natural log of 3 times 2x minus 7. Woo!
Wait, where? You lost them? Yeah. Yeah, but they're right here.
Okay, so I promised you a minute ago we would look at natural log's derivative itself. So do we know the derivative of natural log? No. How do I proceed though? I need to take its derivative. I need to find dy dx. What can I do based off of what we just did a minute ago first? Rewrite it. How can I rewrite this? What's the base? E to the y equals x. Can we take that guy's derivative? Yes. What do we have to use? Implicit differentiation. Because y is the function of x in this case. I know. How do I know that? Because they gave me that. So y is a function of x. So what's the derivative? So now I'm going to do d by dx to both sides. This side I'll do. There you go. What happens over here? E to the y? dy dx. Solve for dy dx. We stopped it for a second. And what was e to the y? What was e to the y? X. Yes?
After you just deleted the derivative, you took the derivative of both. What was this? What did you do from e to the 4th times dy over dx to the next one?
This is y.
To the
From
next
this
one?
to this?
Yes.
Just divide it by this. Yeah. Get dy dx by itself, so divide by this thing I don't want. So implicit differentiation